showing that we can actually make a valve with this method. First, the scaffold was scaled up. It was cellularized with hydrogel cultured for 3 weeks, and then we used a supporting frame to construct the valve, which is quite a common method, at least for in vitro testing for tissue engineering applications. For in vivo testing, this can be replaced with an expandable stent or a bioresorbable stent. But at this stage, as we wanted to test it in vitro, this 3D printed supporting frame would be sufficient. So the valve tissue was constructed, and this is a valve from the arterial view. This is from the ventricular view, and then underwent hemodynamic testing under physiological pulmonary pressures, and showed valvular sufficiency similar to the native valve. This is the pressure profile for the upper side of the valve, and the blue is for the ventricular side of the valve. And you see that the valve is able to create this pressure difference, showing that the valve is not leaky and can perform properly. Also, in terms of the transvalvular pressure in the systole, when the blood basically flows through the valve, the resistance that the valve creates is within the range determined by the ISO standard. So with that, this research is ongoing. The ongoing